Alright, so this presentation is going to be a little bit different. So if you're just on the introduction, you haven't looked at the activity yet, you can pause this and go to the activity, because this video I'm going to go through the whole activity, because this whole activity is a little bit confusing. So I'm going to go through the whole activity as if we were doing it together. So then you can still go through the activity and never watch this video and still be fine. However, if you want some more help, you can watch bits and parts of this video or the whole thing. So just, if you're on the introduction now, just skip it and go to the thing. The reason why it's a little bit, because we're using gel electrophoresis again, so you think, oh wow, that's easy, we've done gel electrophoresis so many times. However, we are going to be using it slightly differently, and we're going to be more in depth. So we know the bands are supposed to match up, meaning they have the same genes, but sometimes those bands don't match up perfectly, or that's very qualitative by looking at. So we're going to make this quantitative. So we're going to learn about how to make gel electrophoresis quantitative, because in science you need those actual data and hard facts to back up your information. So here's the basic vocab. I'm going to be talking about all this vocabulary throughout here, except for cryosurgery. At the end, after you go through this activity, you're going to do an additional one for homework, diagnosing, giving Judy some advice. So Judy is about 41, 42, and she found that, well, she already knows her mother Laura had breast cancer, and her grandfather Bill had breast cancer. And she also finds out that her sister Jennifer, at age 35, was just diagnosed with breast cancer. So Judy's about right at that peak where everybody was diagnosed with breast cancer. So she figures she should probably get tested. And it's kind of fitting that I used the Smith, and Angelina was in the Smiths, because about 2 years ago, she was basically faced with this exact same situation. So what was she tested for? She was tested for these BRCA genes. These BRCA genes are very commonly talked about with breast cancer. However, it's kind of weird. These are most talked about, but only 5% of the people who have breast cancer have this gene. The reason why they're talked about so much is that if you have this gene, your risk from breast cancer goes from 12% to 85%. So remember, cancers are caused by multiple mutations. If you have this mutation of the BRCA genes, which are the tumor suppressor genes there, you also need to have an oncogene there somewhere around. So just because you have this mutation doesn't mean you're going to get breast cancer, but it increases your risk significantly. So that's why they will test this if you have some hereditary cancer here. There's two types of the BRCA tumor suppressors. There's BRCA1 and BRCA2. The BRCA1 mutation is more prevalent in ovarian cancer, and the BRCA2 is more prevalent if there's breast cancer in males. Generally, if you're a male and you have the BRCA2, these are also linked to prostate cancer in males. So now let's go back to Judy and her family. So there's 3 patterns of cancer. I don't have this on the slide, but I'll just talk about it because it's something you need to look at. They're sporadic. Ugh. Alright, so the first type of cancer pattern is sporadic cancer. Sporadic cancer is the most common. Sporadic cancer happens just mainly due to environmental factors, and it's just one day you're diagnosed with cancer. From some type of factor, whether it's skin, the sun, whether it's the food you're eating, various types of things. You wouldn't see a pattern in a family like this. So this one is not sporadic cancer here in Judy's family. Now there's 2, and this is where it gets confusing. There's 2 other types. There's familial and there's hereditary. Alright, so looking at this, you might think, alright, it's all in the family, so it's familial. However, familial is where one close-knit family all has a cancer, and that's due to maybe some genetic factors, but however, there's probably also some kind of environmental factor. So maybe you have some kind of chemical, like radon. Radon occurs in basements of some houses, and if everyone gets lung cancer, that possibly could have been due to radon. And what we would have seen with familial cancer here is that the mom, so see how this just fathers follows a lineage there, you would have seen like the dad and probably the grandmother, if they're all living in the same house, all these people having, or you would have seen neither of these guys having cancer and just this close knit family here, and all these guys getting the same cancer. That's more familial cancer. All right, and then hereditary cancer is what we're seeing here. Hereditary cancer is just where it's almost purely genetic. It's a very small amount of cancers, and you're seeing it's being passed on from one generation to the other. All right, so this is going to be hereditary cancer. Now, the doctor decides to test Bill, and so figuring it's hereditary cancer based on the pattern and this pedigree here. Now the doctor decides, so that's the first thing they're going to do with diagnosing cancers, is look at family history. And then they decide, okay, I'm going to test these two people, or actually Bill is since passed, but we're going to test Laura and Jennifer to see what genes they have, because if it's hereditary, they're going to have to be having some passed genes. He suspects it's BRCA2 because, well, remember on the last slide, Bill had breast cancer, and he's a guy, and BRCA2 is more common than that, and there's no ovarian cancer in the family. So he suggests BRCA2, and after doing a genetic analysis, all the way back from Unit 1, a gene sequencing, all right, he finds that both Laura and Jennifer have the BRCA2 mutation. All right, so after that gene sequencing, they find that. However, gene sequencing is a long process. You saw there's big steps. You deal with that big computer that's sequencing every single nucleotide in there, and that's pretty expensive. Gel electrophoresis, not so much. We do gels all the time in here, so it can't be that expensive if we're doing it in a public school. So we're going to do a gel electrophoresis for Judy to kind of cut down on some costs. And instead of doing, we can't do gel electrophoresis on the BRCA gene because BRCA gene there's been, I think, like thousands, hundreds of thousands of different types of mutations within this one gene that they found. So they can't do our normal restriction enzyme analysis and cut it because there's so many different types of mutations in different places. So what we're going to do is something else called marker analysis. All right, so now we're going to get into marker analysis. So marker analysis, and actually I'm going to pause right now, and I'm going to divide this video up into chunks. So this is just like the introduction there part before I get to the marker analysis.